right. So quick intro. Working for ISV team within Microsoft. So we do a lot of recruits. If you are an ISV, please do reach out if you're working for an ISV. And would love to have a chat on that as well. But yeah, so today I'm going to be talking about Semantic Kernel and Aspire. So they both are SDKs. They're available on, well, Aspire is on .Net particularly, and Semantic Kernel available on 3 languages. So they're available in Python, Java, as well as .Net. And .Net has been GA for a while now. And for those of you already kind of following that community office hours and so on and dialing in, hopefully every month or so, we have that APAC office hours as well. So hopefully you are pretty familiar with that. If you heard of LangChain, that's it. Yeah, it's a office. It's basically a LangChain version of Microsoft in Semantic Kernel. So yeah, so a little bit about me. I work in the global partner solution within Microsoft. Kicked off the APAC Semantic Kernel office hours probably about last October, working with Matthew and Alex from Redmond in engineering, from the CTO of office hours as well. And I also part of the startups and tech sort of employability. It's a branch sort of initiative here. You saw that Microsoft Community Connect. So we do host a number of sessions as well on anything tech and non-tech. So what we're going to cover today. So we're going to cover 3 things really. What we're going to cover in that cover. So first of all, and then we're going to show you an example of how you can build an AI sample, very rudimentary AI app with Semantic Kernel, as well as I'll share a little bit about further learning and materials for you to take a look and peek further. And what we're going to cover, so it's a very brief overview of Semantic Kernel and Aspire. I'm also going to show you the real kind of demo, how it looks like, adding an assistant, or the concept of Copilot. You probably heard about that many times in build. For those of you who here actually saw build or dialed in the build and saw some sessions. Awesome. Yeah. Hopefully you heard Copilot and AI mentioned quite a bit. So it's bread and butter within Microsoft now, and we try to make it as practical as we can. But I'm not going to cover like very detailed walkthroughs of Semantic Kernel and so on. You can I'll share some materials afterwards for you to take a look at. All right. Before we dive into Semantic Kernel and Aspire, what I thought would be good to cover is a little bit about the context of why we're actually doing this. And it's a bit of a kind of business statement, why we actually care about Gen AI, why we care about Copilot and so on. And this is based on Gartner report, and it's been, I think it's 2023 and 2022. I guess the 2 key points here around 80% of enterprise applications will embed some sort of virtual conversational assistant, and the 2025 Gen AI will be embedded in 80% of AI offerings. So I thought that's pretty relevant to what we do here. And if you think of it like the era of cloud, maybe about 10 years ago, we're actually moving to a new era, which is era of AI. And let's dive into the difference between Chatbot, and you probably heard about Chatbot and Copilot quite a bit. So Chatbot is very much a constrained sort of experience where you have kind of predefined context or predefined models. So you probably heard about we did have some AI offerings around that called Lewis before within AI service. And a lot of it is actually, you have to actually train a lot of those, I guess, knowledge before you can take advantage of it. And obviously Copilot which we think is actually a lot more, which offer a lot more than Chatbot, will give you that generative capability, right? So you can, obviously now multimodal is really the the era of multimodal, where people not only talk about in text, but also with vision, with visual, and so on. So a lot of that Copilot capabilities are possible now with generative AI and LLMs. All right. So another thing I wanted to touch base a little bit again as well is about the various offerings within Microsoft when we talk about Copilot. So there's multiple kind of personas, if you can say that. So you can build Copilot using capabilities within Microsoft Copilot, where you can actually bring in your applications and APIs inside of Copilots, and then that extend Copilot, you surface your applications there. And then if you want to create standalone Copilots, then you have different ways there. So you can use Power Platform connectors. You can also use Copilot Studio, as well as OpenAI assistants, and so on. So it's relatively low code experience there. And then we have full control experience, which is where we basically going to be talking about today, is the use of Azure AI Studio, as well as Semantic Kernel SDK, to really build your own Copilot, and you have full control on how you want to manufacture that experience. All right, so why are we doing this? And again, we probably already covered a lot of that stuff. I'm not going to go through this. Pretty much, we want to make user experience as the core experience on that conversational AI and conversational assistant, where in the future people expect you to be able to communicate or allow you to communicate to the application using natural language. So really, that's kind of the key. And the methods of doing that, can be visual, can be text, can be via webcams, etc. So it's basically a natural way of conversing with your application. The next thing that I'm going to talk about then is around these two favorite stack that we talk about, right? So Aspire and Semantic Kernel. So I'm going to cover Aspire first. And by the way, that went GA of I think 2 weeks, the past 2 weeks in build, where .NET Aspire is a really, I would say it's a dev tooling, a very powerful dev tooling that really allow you to, basically the notion of shifting left in terms of getting feedback. So in the past, you would probably see that if you want to build an application, enterprise application, you have to actually feed those logs to, APM or some sort of performance management tooling. So you can actually have that dashboard experience integrated as you develop the application. And you probably, I'll show you a couple of demos there. But yeah, really, it gives you a lot of building blocks. So, things like, poly, ability for you to retry logic, and so on. That's available for you as part of the service default capability within Aspire. And also, there's a lot of packages or components, you call it, within Aspire, where you can actually connect to, like, service bus or Redis or databases and so on. So you don't have to kind of build the plumbing for that. It's all kind of built in for you. And big one for cloud native application is around service discovery. You probably heard it's always DNS. If not DNS, it's always usually the DNS. So, and it's pretty important when you develop cloud native, your service discovery is taken care of. And as you build and deploy your application, you'll see that a lot of those DNS kind of resolution and so on, that's built in within Aspire for you to actually use and operate. So an example of that here. So it's a bit, probably, I'm not sure you can see that. But yeah, this is the kind of the main part of Aspire where you can actually stitch together different components. As you can see here, we've got builder, kind of the file builder here, and then you can add caching as well in here. Where basically at Redis, and you also have ability to then connect your APIs or your project. So this is an example of just an API with a database or with some backend. So you have an app host project, which is you think of it like a container that allows you to collection of those different resources that you basically connect together and stitch together there. So you have caching, you have API service, and you have the front end project, right? So it's always projects in the world of .NET, as you well aware. All right, so that's a little bit about Aspire. I wouldn't go through the detail of that, but I'll show you how that's beneficial in your build, in your application. And for those of you, has anyone tried Aspire, by the way? So that's awesome. Yeah. What do you like most about it?
I like more about the tracing, how they can see the request received.
Nice. It's amazing that you have that. It's an OTel, open telemetry, that's built in within that. So that's brilliant. Yeah. Great. I love that as well. I'll show you that it's all built in GA now, and in container apps you can actually access that across, which is brilliant. All right. So next is Semantic Kernel, right? So I'm going to introduce Semantic Kernel, but the first thing is understand what is agent? What is an agent? So, and there's a lot of people talking about agent these days, but really the key thing about agent is it's gonna really change the world in a way that you probably would have thought not really possible. And we talk about it since agent is almost like a automation engine, right? So a lot of people think about agent is like a replacement or some sort of assistant, and that's not entirely correct. But really the main thing is you have a set of ingredients to build an agent, and we have basically a definition here. So an agent consisted of persona, models, data, as well as functions. So persona is basically that behavior that you want to actually inject within your agent. So typically it's basically that system prompt that you define. And models, again, we have LLMs, we have SLMs, we have fine-tuned models as well. Again, I probably want to share a little bit why fine-tuning is always usually not the answer because it's very expensive. But yeah, LLMs, large language model, SLM, small language model. And then now we're also seeing models actually being embedded in the edge devices, right? So basically, in your phones, in your fridges, on your microwaves and so on. So that's really getting to the trend now, where you probably, if you play around with SLMs, you can download some models in less than probably 3 gig, 2 gig type thing. So it's very, very small, and you can play around with that. And data, obviously. So you heard of a RAG, right? So retrieval augmented generation, where it actually like give LLM some pointers, right? So ability for LLMs to basically search particular knowledge, whether that's files, whether it's database, different data sources. And then we also have knowledge graph. So knowledge graph is you heard of graph, Microsoft Graph. So basically talking about or exploring relationships between nodes. And also we have databases, right? So SQL, NoSQL, structured, non-structured, NoSQL sort of non-relational databases as well. And functions, so basically functions are, APIs, code interpreter. So APIs is basically ability for you to interact with outside world. For example, if you ask ChatGPT, what's the weather today, probably won't know, unless you probably pay the GPT Plus. And also, if you want to get the time and basically understand the real time or real world sort of situations. So yeah, basically agent allows you to build that enrich capability or enrich the capability of that. And Bill Gates kind of mentioned that this is going to be really biggest revolution in computing. If you think about it, like we want to put PCs on everyone's desk, a while back, 1980s, whatever. Now we want to put, in a way, agents in everywhere. Cool. So what is semantic kernel? So basically, without further introductions, basically we want to make it easy for you to build agents, right? So that's basically what's SDK that allows you to build agents, and it's almost like a what do you call it? Like a Swiss Army knife where you can actually swap different plugins, different state models as well. So you can apply Gemini, if you want to. Again, I don't recommend it, but anyway. And if you want to go with SLM as well, so you can do that. And then more importantly, run the plugins and the memories, such key as you build agents. And we have a lot of connectors as well built in within semantic kernel that are also built by the community. So if you want to connect to Elastic and various databases, Qdrun and various things, we do have connectors for that. So again, semantic kernel is really the core of that is inside of the kernel itself, right? So the kernel holds all of these, right? So ability for you to add plugins, planners, personas. Again, planners is another concept that I'll probably won't cover too much today, but you can take a look at it in the resources that I'll share later on. And personas, effectively that system prompt ability for you to, tell or provide additional context for the LLM to provide response in. So yeah, so with that, I probably gonna move on to a quick demo. Any questions so far? Hopefully that's clear enough. Yeah.
You had Azure AI Studio and
Yeah.
Semantic Kernel listed under each other, but is Azure AI Studio actually using Semantic Kernel under the hood? Is it just a UI interface into that, or?
Yeah, that's a good question. So the question was, Azure AI Studio and Semantic Kernel, whether Semantic Kernel powering Azure AI Studio, what sort of relationship it has, and so on, right? Really, Azure AI Studio is the umbrella, if you think about it, like a suite of tooling that allows you to access different Azure AI services. So whether that's LLM, whether that's APIs, or we have another tool as well around content safety, which is security and so on. So it's umbrella of all that. And Semantic Kernel is basically one of the services that you can access or build using AI Studio. Semantic Kernel itself, again, we're recording this. It's effectively, in some shape or form, it's actually powering Bing, well, now it's called Copilot, and also, all the Copilot within M365 actually adapted from Semantic Kernel. Again, not exact implementation of Semantic Kernel, but the team actually worked together to build Copilot and powered by the Copilot by Semantic Kernel. So you've probably seen a lot of the same terms, in Copilot, like extensions, plugins and so on, and that's basically brought and adapted from Semantic Kernel. Yeah. And if you ask about, hey, has this been battle tested? Yes, it's been. Yeah, well, you're probably using it every day without knowing. So, just good. Yeah. So, why are we doing this? So that's pretty much the whole topic today. Dotnet Spire and Semantic Kernel feel that it's made for each other, for AI apps particularly. As you build, I guess, more interactive applications and you build cloud native, they really easy to be made or work together, because Dotnet Aspire hones in on that, providing that first class experience for dev, and then Semantic Kernel makes that building agents that easier for you. So I've got this little demo, and I think for those of you, I'm not sure if you saw previously in the Reactor talk, I did a very rudimentary on how you can actually power up your pretty much a what do you call it, shopping cart application that allows you to kind of build your application if you have like an existing shopping cart application, and then you can allow or add some assistant within that, and you can use Semantic Kernel for that. So I have a very simple application. It's based on Aspire Shop, which is a sample that Damien put together. And also, this is Damien Brady, for those of you who don't know, and he kindly sort of gave me some big guidance on that hey, you've just used this because it allows you to demonstrate the power of Semantic Kernel. And what I did is pretty much just adding that green components, right? So I've got chat service, which is a container app. It's all basically container app within Aspire at this stage anyway, and we basically just hook it up with LLM, Azure OpenAI. And what that looks like, it's pretty much a, like a not chatbot, it's a Copilot, and it allows you to kind of bring in. Oh, by the way, that's not the right version. Actually, use the GA version now. So I need to update this slide. But yeah, you can trust me that I'm actually updated. I already updated with the latest GA version. And the .Net SDK as well is also the latest as well, 1.13 if not mistaken. And what it is basically allowing you to ask questions in natural language, right? And then not only giving the answers, but the Copilot giving you the answers, but also bring you into that particular, if I ask for T-shirts, it should navigate me to those T-shirts, right? So that's basically what's going to be. Let me see if I can just change that a little bit. Here, hopefully I've tried it before and it worked. We'll see. So basically, we've got this container app here. It's basically based on Aspire Shop, right? And we have just bunch of items here in product catalog, and I'll show you the actual. Oh, sorry. Thank you. Good one. Good call out. Excellent. So that's what we have here, and thank you for that. And hopefully you guys can see that okay. Yeah, so it's a Aspire Shop that's deployed, and basically what I did is basically add this assistant in here, and the text here, it's basically quite static. You can make it as custom as you want. You can call LLM if you like. To create greetings. I know that some experiences that you want, for example, if I navigate to a T-shirt or navigate to a particular item, then you can provide a contextual greeting as well, so that it actually looks at, hey, script the website, what it looks like, and then gives you, hey, do you want to know anything about this T-shirt or want anything about this mark and so on. So what I have here, again, hello, hopefully. This works okay. So this one here, if I say hello, I'm sorry I'm unable to assist with that request and blah blah blah. You can customize the experience. This is something that I intentionally ensure that the questions and the queries and so on, the prompts are really should be relevant, right? So it should only related to catalog items of this. And there's a plugin that you can actually add as well in here as part of that. So I'm sorry I'm unable to ask that question. So let's say, show me all hoodies, for example. And there you go. So I've got 3 hoodies there, and then kind of give you the items as well as kind of navigate you to that. And it's very, very simple, right? So it's not a, mind-boggling sort of ability. But if you think about it, you get an idea where you can actually make the experience as relevant as possible. You could change the chatbot as your complete assistant in there, so you forget about the website in a way, and just create carousels and various UIs and so on in there. And you can add cart, you can process transactions and everything else, just as if you go to a store and talk to an assistant in real life, right? So that's kind of the idea there. Again, it's not fully functioned feature, but I just want to show you a quick demo of that. I'm just going to show you quickly the code. So let's see if I can probably get this one here. It's okay. Hopefully I can got Copilot chat as well. I did ask about that question about using statement before, so thank you, Nadi, for that. So I'm going to ask about that with Copilot. But anyway, what we have here is basically the Aspire shop here solution, and we have a service called Chat Service, a project here, and I've added basically an API in here using controllers, and what I have here is a bunch of code that kind of deal with the actual prompting, and then the creation of intents, as well as plugins, right? So these are kind of the three ingredients, if you will, and let me know if you can't see that. So basically, the first thing is to load prompts, and then second thing is to load intent, and then finally added that as plugin. So there's basically load prompts, and load intent is basically that personas, that we talked about agent before, run personas and system prompt, and what we have as well within here is to wire up a lot of the ability for you to call APIs, but that's not within this controller.
Sorry, Vic, so the load prompts and load intents, are they, what are they loading? Is that content from files?
Yes. So I'm just about to go through that. So the load prompts, basically I've refactored this again. Hopefully it meets Nadi sort of good practices in a way. But yeah, anyway, it's basically ability for you to, there's two functions within, or two functions within Semantic Kernel. One is called semantic, and the other one is called native, right? So semantic is more like prompt-based type function that allows you to kind of tell LLM in a natural language, and native is more of an API, search, retrieve information, and so on, right? So what we have is a semantic function in here, and I've got within the plugins directory, just open that one, and as you can see here, probably a bit too small. And this is basically what I tell my assistant to behave in a certain way, right? So I gave a number of things in here. You are an AI assistant that helps people to find certain information within here. And then if you found some sort of catalog items, only mention the name and the price and so on. And I provided what we call few shots examples, right? So for example, hey, can you show me red t-shirts? And then he's basically an example of that response, right? So I found only one red t-shirt, which is this. Can you show me what t-shirts? And these are some examples as well there. And basically these two here are pretty much a kind of a variable substitution that allows you to add what we call history, which basically to understand different previous chats, and then adding that request, which is the prompt that you pass in that chat assistant bot in there. Again, I want to move away from chatbot, but that's pretty easy to get mistakenly. And this one here is a config.json, which is a list of, I guess, settings that you can provide within your models. For example, if you want to connect to SLM, Phi, GPT-3.5, GPT-4, you can provide some attributes or some parameters in here. So for example, GPT-4, I'm using this. Again, probably not the best model now. GPT-4o just released. Anyone tried GPT-4o? Yeah, it's amazing, right? It's really, really quick. And the max tokens is very important. It's good to actually set that out for every sort of interaction. It's basically defining the maximum tokens for your output, right? So that way you can maintain, your costs and manage your costs and everything else. So because everything is by tokens, right, within LLM. And temperature is basically the level of creativity, hallucination, if you call it, and typically for this type of scenario, you want to keep it low, right? So that's that. And the second one that I'm going to show you is this one here, which is the native function. Native function, or basically a plugin is consisted of multiple functions, right? So I have only one function in here, which is called filter catalog items. And what it is, effectively, it is making a call to the catalog service API. I've got a kernel function here, return a list of catalog items filtered by name or description. Again, in the multimodality world, you ideally want to be able to scrape the image and understand, what that looks like. Because if I ask, like, give me all the purple hoodies, or maybe with a particular letter and so on, you wouldn't be able to do that with this currently. So you need to use a different model for that. What we have is effectively just calling this catalog service, which is an HTTP endpoint, an API that allows you to basically return items. So within the catalog API here, added additional function, which is ability for you to search, right? So that's pretty much this line here. So ability for you to add search, again, is based on Dotnet EF. And it allows you to then return the results and pass in the whole results there. But let me go through this first, right? So basically, the load prompts and the load intent and the plugin. So the plugin is already baked in within the dependency injection within our chat service. Let me just go through that. Again, we've already made some updates to this, so I need to refactor this a little bit to make it a little bit more less manual object instantiation as a good practice in there. But yeah, effectively here is added or furnish with plugin call that filter catalog item in here. And within the chat controller, let's go back to that. We have basically created this whole task, post message, and we have this get intent and handle intent. So the get intent and handle intent is basically that, you saw initially when I asked hello, and it actually returns, we can't help with that because of such and such. Basically, I added those intent in here. Let me just go back in here. Again, it's pretty self-explanatory in here. Again, it's probably a very busy switch statement. As you can see here, switch intent, and then end conversation, all items, and unrelated. And then basically, if it's not in any of this statement, then we will proceed, right? So it's basically trying to catch that phrase early. So if someone actually asks about, oh, I'll finish with this, with this shopping, then I will just, rather than adding or getting LLM to process that response, I will just end that early. That way, you save a little bit of tokens as well as part of that. And then all items, I'll say, okay, we'll just go back and then provide that intent, which is that space, which is a search for all. So if I go back to my demo as well, give me all items. That effectively will just pass in blank within the search text in there, in the parameter there. And that's basically going through this, here are all items. And then unrelated, basically, I'm sorry, I'm unable to assist with that request, and so on. So it's all kind of hard-coded sort of thing. And this is where you see that the interaction, if you will, with LLM, that allows you to talk and basically make a call to LLM, and then use some sort of object that allows you to kind of pass them through and then go through that. And once you kind of get that result, that will be passed into the front end, and then you'll see those results. So it's not very, very complicated, as you can see. Hopefully it's easy enough for you to follow, but there's a bunch of examples within Semantic Kernel. There's lots and lots of examples, but this is a kind of a real world sort of example of representation of how you would take advantage of Semantic Kernel. Yeah. Probably this one is interesting. This one here called author role equal dot tool. So anyone heard of function calling within OpenAI? Yeah, awesome. So basically we have two ways to kind of orchestrate our plugins. So we have launched a lot of plugins. So like weather, in this case I've got get catalog items, but you can add so many stuff, right? So for example, if you want to ask the stop assistant to say, hey, I'm going hiking next week, what I'm going to do, there's a bunch of plugins that you need to orchestrate, right? So where you want to go, what's the weather for that location, what's the next week date for that, right? So that basically needing you to orchestrate your plugins, and there's two ways. So one is function calling, and the other one is planners, right? So function calling is a built-in sort of orchestration within LLM, if you will, that allows you to basically pass in a request and then allow LLM to choose the right plugin for you. And how do they choose the plugin? It's based on those description tags that you provide, right? So if you go under plugins here, under filter catalog item, you see some of these description sort of designation in here, as well as that function. Basically, LLM actually looks in that and tries to make the best guess for that which function that you want to call. And the other method is called planner. Again, I'm probably going to leave that later for you to take a look at, but it is very good for a well-defined process that don't change a lot, right? So if you've got like a well-defined processes that you want to automate and then you use agent for that, then planner is good because it allows you to inspect the kind of the ins and outs before you actually send to LLM and allow you to manipulate. Okay, so that's it from my demo, and then I'll probably going to go back to the slide. And talking about Aspire. So in terms of Aspire, it's very, very self-explanatory and it's very simple, but you've got this amazing dashboard, right? So I don't know why it's black, but anyway. Hopefully you guys can see that all right. But basically we have a number of containers in here. So we've got basket cache, basket service, catalog, and so on. And we have this chat service, which we added as part of this, right? So we have a chat service project, and a chat service is basically an API, right? It's an API that allows you for you to take a look at. Again, you can't access it because this is not accessible from outside, but if you do a local development, you'll be able to access the Swagger, or if you enable that, for you to actually use. And the front end, obviously that UI. And then you see this a number of traces and logs and everything else based on OTel that allows you to kind of debug that early, which is brilliant, right? So you don't have to wait until it goes to some sort of SIT environment or integration environment for you to actually take a look at. And the traces is really, really good as well. Again, I need to probably log in with this. And that's, just go back to that. There you go. There's a bunch of stuff there giving you the APM insights and so on. front end, catalog servers, basket servers, and so on. And probably if you do talk to chat servers as well, that's going to be made available there too. And within the container apps experience, you'll probably see that there. It's under here, .NET Aspire Dashboard. I don't know whether this is something really, really brand new, but I certainly just saw it recently. So that particular .NET Aspire Dashboard on the bottom there. So yeah, definitely if you want to play around and try Aspire, definitely it's a great tool under your belt to try. Yeah, with that, I'll leave it to kind of the further learning. Again, the front end part is very, very simple. Just UI stuff, bunch of CSS, and a lot of questions and answers from Copilot. Okay, Copilot, because I'm not a UI person. And in terms of future improvements, so what we're doing is effectively talking to service and API. However, it would be great for us to be able to move that, remove that sort of intermediate sort of communications between API and API, and just allow you to connect your LLM directly to your database, as if like ability for you to store memory, to store your database into a memory, and then LLM can then talk to it, right? So we have a project called Kernel Memory, which is a sort of a playpen project that, for example, if you've got like all of your catalog in a database in Postgres, whatever, you can index that data and create embeddings effectively that allows you to then make that compatible with your LLM for you to then be able to talk and ask questions directly there. That way you don't need like APIs and all that stuff to stitch together from chat servers to catalog servers. You can just go straight giving access to kernel memory to catalog database. But again, it comes with I guess territory around what sort of access and everything else that you need to be aware of in providing that. But again, it's very, very another topic that we probably can talk about, but this concept here is called retrieval augmented generation. So effectively moving or indexing your data set and then putting them into a stored database. Yeah, so that's it from my side. Further learning, a bunch of links there. Again, probably I'm going to share that slide later on. And bunch of community office hours. We have one next week on, I think, Thursday. Discord, we do have Discord as well. We have discussions, and that's my repo as well for you to take a look at and provide comments, and don't forget to leave stars as well. Great.